Hey guys, welcome back. Unfortunately, the class we just had, my internet went down and I couldn't complete the class. In fact, I had just started it, so I'm gonna go ahead and do the whole lesson here on YouTube. And then if you have any questions, you can just go ahead and have your parents email me, or not email, but text me, or get in communication with me via Teams, or just post it over here on YouTube to post your question right there. Okay, so today we're comparing fractions, and this is the third part. The first part, we compared fractions with different denominators but same numerator. In the second part, we had same denominator but different numerators, and now we're going to compare fractions which have numerators and denominators that are different. We're going to compare them. Okay, let's go ahead and before we begin, let's make sure we know our classroom commitments. Okay, so the things we promise to do: we promise to be respectful, we promise to be focused, and we promise to be engaged. So be respectful. Always make sure that you watch what you say. Think about it before you say it, because if you harm someone, you really can't take it back even if you apologize. So don't put yourself in that situation. Just before you say something, think about it. Be focused, guys. I know that right now you're watching this class on YouTube and you have other things that you might find more interesting, but remember, if you're here, if you sat down, if you started watching the video, you probably had the intention of watching it so you can learn something. So stay focused. Look at the video. Don't be listening to music. Don't be doing other stuff. Be focused. Be engaged, guys. Now, I know this video is on YouTube and it's not live like the way we do it through Teams, but be engaged. Have your pencil and have your paper and try the exercises. Think about what I say. Don't just let me speak. Think as I'm saying. Pause the video. Look back and study the material, okay? Now, I also want to go ahead and cover the requirements for this class, guys. This is the summer class, and if you're here, it means you need to be here, or it is good for you to be here. You are here because you want to learn and get better for the grade you're going into. Whether you're going to 4th grade or you're going to 5th grade, you want to make sure you meet the course requirements. So, to pass a summer math class for 3rd and 4th grade, you need to do at least 120 minutes of Imagine Math. 120 minutes is 2 hours, okay? So what I suggest is that you do 30 minutes every day, Monday, Tuesday, Wednesday, and Thursday, okay? That'll be the same as 2 hours. Now, if you don't like my idea and you want to do 2 hours over the weekend, that's your decision, but make sure you get at least those 2 hours. Then you have to be actively participating in class. When we do this live classes, I want you answering. I want you to be ready when I call you. The next thing you need to do is you need to complete any additional assignments. You have 2 assignments already, so complete those. Make sure you get them done, okay? For math class. Oh, one more thing, you must pass 12 lessons by the end of the summer. So if you do your 2 hours, you should be able to pass those 12 lessons. The better you do, the more lessons you pass, the more time you spend, the better your grade will be. Okay. For summer reading classes, a little bit simplified. You're gonna do your 30 minutes of Imagine literacy every day from Monday through Thursday. That's the suggested plan. Or 120 minutes is really what you need. It's really what's recommended. So if you do your 120 minutes per week, then that'll help you get a really good grade. Plus, you have to be actively participating in class, and you must turn in any additional assignments, okay? There's not many additional assignments in reading, just because I really want you to focus on that Imagine reading. So make sure you get that done. 30 minutes of Imagine reading, 30 minutes of Imagine math, 4 times a week, okay? Let's go ahead and now let's go ahead and do a little review, okay, guys? So we began all these days that we're doing fractions. We began by reviewing the vocabulary, okay, guys? The vocabulary is very simple. Here we have a fraction. This fraction's 3/4, right? We say 3/4, and basically that means that we have my numerator is the number on top of the fraction, and this says the number of parts you selected, not the number of parts that are shaded, but the number of parts you selected. If you're interested in the shaded parts, then this 3 would be the number of shaded parts, okay? The 4 on the bottom of this fraction, 3/4, is the denominator. It tells you the total number of equal sized parts in the whole. So this tells you how many parts you cut your whole into. Alright, so then here's how this fraction would look like. If we say 3/4, we're interested in 3 parts shaded out of 4 equal parts, and that's how you get 1/4, 1/4, 1/4, 1/4. But you only shaded, or you only needed 3 parts: 1/4, 2/4, 3/4. So you have 3 out of 4 pieces. How many parts are not shaded? 1/4. 1 out of 4 is not shaded. Okay. So make sure you understand that basically the main thing is what a numerator is and what the denominator is, and to make sure that the numerator, you think of it as the number of parts selected. That's very important. Alright, the next thing we did was we compared fractions when the denominators are different. And this is the case here. We have different denominators, same numerators. So we said if the numerators are the same, notice over here that your numerators are the same. You have 3/4 and 4/8. Your numerators are 3 and 3, right? So 3/4 has a numerator of 3. 3/8 has a numerator of 3. So that means you selected 3 parts in each. If the numerators are the same, then the fraction with the highest denominator is the least. Okay? So we hear 3/4, the denominator is 4. 3/8, the denominator is 8. Now, because we have same size wholes as represented here, here you have 3/4 and here you have 3/8. Because we have the same size wholes, but the whole is only cut into 4 pieces, and on 3/8 the whole is cut into 8 pieces, that the more cuts you make, the smaller the size of the pieces. So even though you picked 3 pieces on 3/4, those are bigger than the ones you picked on 3/8. So that rule is very simple. When the numerators are the same, you can just ignore them at that point and focus on your denominator. The fraction with the lowest denominator, that one will have the greatest size pieces. So that's going to be the greatest fraction. Okay? One last time. When the numerators are the same and the denominators are different, the fraction with the lowest denominator will be the greatest. Okay? Then on day 2, we compared fractions when they have the same denominator and different numerators. This case is very simple. Here we have 4/6. That means we have 4 out of 6 parts selected. 4 out of 6. Okay? And here we have 2/6. So if the denominators are the same, 4/6, my denominator is 6. 2/6, my denominator is 6. Then the fraction with the highest numerator is the greatest. So that says that since the wholes are cut exactly the same way, then the one where you pick the most pieces is the greatest. So that means that 4/6 must be greater than 2/6. Today we're going to be comparing fractions when the numerators are different and when the denominators are different. Okay. To do that, we're going to have to take 2 steps. First, we're going to find an equivalent fraction. Once we get that equivalent fraction, that means our denominators are going to be the same. So all we have to do now is compare numerators. When the denominators are the same, remember that the fraction with the highest numerator will be the greatest. So let's go ahead and look at this. Let's go ahead and compare 1/2 to 3/4. Okay. Now in 1/2, my numerator is 1, and 3/4, my numerator is 3. They're different. In 1/2, my denominator is 2. In 3/4, my denominator is 4. They're different. So here we have different numerators, different denominators, and of course they're gonna be the pieces are not gonna be the same size. So we really shouldn't just compare them like that. But one thing we can do, as always, we can go ahead and just draw them. Okay. So let's go ahead and draw or shade in 1/2. Okay. And let's shade in 3/4. And it's obvious from the drawing that 3/4 is greater than 1/2. But remember, what we want to get used to is to make sure that we have the same denominator on both. So how can I get this to look just like that? How can I get 1/2 to look just like 3/4? Well, if you said cut it down the middle again, then that's right. So now you're going to see that 1/2 becomes 1/2 equals to 2/4, and 3/4 stays the same, right? Didn't change because we didn't do anything. So now we see that we have the same denominator, so the fraction with the greatest numerator is the greatest. So that means that 2/4 is less than 3/4, which means that 1/2 is less than 3/4, because 1/2 is the same as 2/4. Okay, that's what we're going to be doing in the following exercises. So here we go. Okay, so in our first exercise, we're going to compare 2/3 to 3/6. Now here the denominators are going to be different and the numerators are going to be different. So we're going to remember the fact that when we compare fractions with different numerators and different denominators, we first find an equivalent fraction, and then once we have an equivalent fraction, we'll have the same denominators. We'll use the fact that when the denominators are the same, the fraction with the highest numerator is the greatest. Okay, so let's go ahead and do that. Okay, so here we have 2/3. So let's go ahead and shade in 2/3 as do what we already know. Go ahead and shade 2/3, and here we have 3/6. Okay. Now, you might say automatically, yeah, Mr. Medina, when I see that, I can see that 2/3 is more than 3/6, and that's true. I mean, visually you can see that it's true, but what if your drawings are a little bit off? So let's not go by the visual evidence. Let's go ahead and look at mathematical evidence in a few seconds. Okay. So, but let's get them to be the same size. So let's extend that line right down the middle. Let's get them to have the same denominator. Let's find the same denominator, and there you go. So if we convert 2/3 into 6, what we find out is that we're gonna get 1, 2, 3, 4, 5, 6. 2/3 is the same as 4/6, and of course 3/6 we didn't do anything, so that'll be the same as 3/6. Now we have the same denominator, so all we need to do is find the fraction that has the highest numerator, and that's this one. So that means that 4/6 is greater than 3/6. So that means that 2/3, because 2/3 is equivalent to 4/6, must be greater than 3/6. Okay, and that's problem number 1. Was that simple? Sure it was. Now you try the next one. For this next exercise, we're going to compare 3/4 to 4/8. I want you to try it, put pause, and then check it when I do it. Okay, so go ahead and put pause, and then hit play when you're ready. Okay, and check your answer out. Okay, so let's go ahead and let's remember the steps you need to take. Okay, so the main thing that you're going to have to do is to compare fractions when they have different numerators and different denominators. As the case is here, the 3/4 has a 3 as a numerator, 4/8 has a 4 as a numerator, so they're different, and the denominators in 3/4 is 4, the denominator on 4/8 is 8, so they're also different. So this is the case. So when you're going to do that, you're going to find an equivalent fraction. When you find that equivalent fraction, you'll have the same denominator. At that point, you can just compare the fraction with the greatest numerator will be the greatest. So let's go ahead and do that. Okay. Now, first thing I want you to do is just go ahead and shade what you see, 3/4, okay, and shade 4/8. Now you can see, you will be able to visually see that when you compare one next to the other, you will see that obviously 4/8 will be less than 3/4, but we can't go by that. We have to let's go ahead and cut them the same way. So what I'm going to do is move this down here. Now remember, you can do whatever you want. You just want to make sure you try. Okay, so let's cut them the same way. So we're gonna find an equivalent fraction. So I'm gonna make a line right there, and I'm gonna follow this line and make it right here. And notice now that we now have equivalent fractions. Okay, let me move it back to its original place. Okay, oops, I have to move it exactly back because one more try. Let me move back to its original place. Okay, now we have 3/4 became 1, 2, 3, 4, 5, 6, 7, 8. It became 6/8. So 3/4 is equivalent to 6/8, and 4/8 didn't change, so that stays the same. Now we have the same denominator, so we now need to get a new. Now we need to compare numerators, and remember when the denominators are the same, the fraction with the highest numerator is the greatest. So this one's the greatest. So that means that 6/8 is greater than 4/8. So that means that 3/4 is greater than 4/8, because 3/4 is the same as 6/8. Okay, I hope you got that correct. It should be pretty simple to you. Let's go ahead and do the next one. In this section, the third and final exercise is comparing 2/8 to 1/4. Okay, so let's remember when the numerators and denominators are different, we're gonna take a two-step approach. First, we're going to go ahead and find an equivalent fraction. Once we have equivalent fraction, we're going to get the same denominator, so we're just going to compare the numerator. The fraction with the greatest numerator will be the greatest. Alright, so let's go ahead and look at this. Okay, so we have 2/8, so let's go ahead and shade in 2/8. Okay, 2/8, 1, 2, compared to 1/4. Okay, now I really can't tell which one has more with just my eye. So I'm gonna have to do some math, and really we should always rely on the math and not on drawings, okay? But when I put them right next to each other, I did that so I can go ahead and just copy the lines. So I'm gonna bring that line down because I want to cut them exactly the same. Okay, and I'm gonna bring this line down. Okay, and now it's easy to see. Okay, now we can see that. Now, we didn't do anything to the 2/8, so we have that 2/8 stays the same, but an equivalent fraction for 1/4 is 1, 2, 3, 4, 5, 6, 7, 8. Notice now we have the same denominator. This is an 8. Okay, so this is going to be 2/8. So 2/8 is 2 out of 8, and 1/4, if we turn it into 8s, becomes 2/8. So that means that 1/4 and 2/8 are equal. Okay, so 2/8 is the same as 1/4, because 1/4, when we find an equivalent fraction in 8s, we find that it's 2/8. So those are equal fractions. That was pretty simple, guys. Let's go on to the next one. Hey, in this next exercise, we're going to compare 3/9 to 2/3. As you can see, the denominators are different. A ninth is nine pieces out of the whole, and a third is 3 pieces out of the wholes. The ninths are smaller than the thirds, but the numerators are also different. So in the ninths, we actually selected 3 pieces, so it's 3/9, and on the thirds, we selected 2 pieces, which is 2/3. So let's go ahead and quickly shade those in, okay? So here we go. 3/9 versus 2/3. Shade different colors, okay? And you can quickly see that it appears like 2/3 is going to be more. So, but it's always good to go ahead and cut your pieces the same way anyways. So I'm going to just move this a little bit to extend my line. So what I'm going to do is I'm just going to extend my lines. Okay? So I'm going to go ahead here. I'm going to extend that line all the way across. Okay? And I'm going to extend this line all the way across so that we end up in 9s. And now we're comparing 9s to 9s. And that way we are for sure that we have the right thing, okay? Because even if our drawing is inaccurate, we're actually comparing. We know we have the same denominator. So here we go. So notice that, first of all, notice that 3/9 we didn't do anything to it. So 3/9 will stay as 3/9. Okay? So 3/9 didn't change. That stays as 3/9. Excuse me. Hopefully 3/9 stays as 3/9, but 2/3 we wanted them to be the same, so 2/3 actually became 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2/3 became 6/9. So we end up comparing 3/9 and 6/9. Now we have the same denominator. So when the denominators are the same, the fraction with the highest numerator is the greatest. So this is the greatest. So that means that 3/9 is greater. 3/9 is less than 2/3 because 2/3 is the same as 6/9, and 6/9 is greater than 3/9. Okay, so that's that exercise. Let's go to the next one. So problem number 2 asks me to compare 1/2 to 2/3. Halves are bigger than thirds, but we only picked one part out of the halves. In the thirds, we picked 2 parts. So let's go ahead and just shade it in the way we know. 1/2 and 2/3. And it seems pretty obvious that that 2/3 is going to be more, but we can't always go by what seems obvious. So what I'm going to do is I'm actually going to do something a little bit different right now. I know how to make a half, so I'm not even going to worry about making a half. What I'm going to do is I'm going to turn 2/3. I'm going to put the line that represents a half right here, okay? I'm just going to make a line right there to represent the half. Okay, now notice that my 2/3 was made into 6s. Now let's go ahead and put my half right here. Okay? Because I know what a half is, right? But remember, I want to compare them. I want an equivalent fraction. I want both of them to have the same denominator. So what I'm going to do is I'm going to come down here now and let me shade my half, because here's my half, right? But now I'm gonna bring these lines down. Okay, I'm gonna bring those lines down to also make them into 6s, because I want to compare same denominator. And now I want you to notice, now that I did it, I want you to notice that 1/2 became 1, 2, 3, 4, 5, 6. It actually became 3 6s. And 2/3 became 1, 2, 3, 4, 5, 6. It became 4 6s. Now it's easy to compare. My denominators are the same, so that means the fraction with the greatest numerator, which is this one, is the greatest. So that means that 3 6 or 1/2 is less than 2/3. I want you to notice that I could not make them both into thirds, and I could not make them both into halves. So I found a common denominator by cutting them both into 6s. And that's how we're going to be able to do that mathematically later on, okay? But now it's just visually. So now let's go on to our last exercise. Okay, for today's class, you're going to be comparing fractions when they have different numerators and different denominators using the cross multiplication method. Your teacher will show you other ways. This is just one way to be able to find an equivalent fraction, so that you can then compare the numerators and see which one's greatest. Okay, but your teacher will be showing you different ways. Okay, this method works, but do the method that your 4th grade teachers and 5th grade teachers teach you at the moment they teach you, okay? So, but this is still a good strategy to have, okay? So here we go. So when we're going to compare two fractions that have different numerators and different denominators, we need to find an equivalent fraction. So let's look over here. Here we have 3/4, right? And here we have 2/8. They have different numerators and different denominators. Different numerators, 3/4 has a 3, and a 2/8 has a 2. That's different numerators and different denominators. 3/4 has a 4 as the denominator, and 2/8 has an 8 as the denominator. Okay. So what we do is we cross multiply. So we're going to multiply 3 times 4, and that is 24. And then we can multiply 4 times 2. That's why you call it cross multiplication. Cross multiplication, that's 8. And then we're going to multiply the denominators together. And 4 times 8, that's 32. So now let's see what we get. What is the equivalent fraction we get? We get 24, 32. We write the same denominator compared to 8 32nds. Okay, so which is greater? Well, now we have the same denominator, so the fraction with the greatest numerator is the greatest. So 3/4 is greater than 2/8. Okay, and that's the way we can prove it. Now let's go ahead and do some exercises. So using the cross multiplication method, let's compare these two fractions. Okay, now these fractions are, this is 2/3 compared to 1/2. Okay, so if we're going to do the cross multiplication method, we have 2/3 and 1/2. First, we're going to compare, we're going to multiply these two. Okay, so that means that we're going to have 2 times 2. Then we're going to multiply, cross multiply over here, 3 times 1. Finally, we're going to multiply the denominators by themselves, okay? And that's going to be my denominator down here. So this is going to be 3 times 2 and 3 times 2, okay? So, what do we get? So what's 2 times 2? Well, if you know, that's 4. What's 3 times 2? That's 6. When we multiply over here, what's 3 times 1? That's 3. What's 3 times 2? Because we write that on both. That's 6. So 3 times 3, 2/3 compared to 1/2. 2/3 is the same as 4/6, and 1/2 is the same as 3/6. So now that we have the same denominator, the fraction with the greatest numerator, that's this one, is the greatest. So what does that mean? That means that 2/3 is greater than, is greater than 1/2, because 2/3 was the same as 4/6 and 1/2 was the same as 3/6. So that's why this is greater. And we shouldn't prove it, that should convince you, but if you would like, you could just imagine you cut this into right there, and you cut this into thirds. Okay, so you would have to cut this into thirds, and you could see that 2/3 would be the same as 4/6, and 1/2 would be the same as 3/6. So 2/3 would be greater. Using the cross multiplication method, we're going to go ahead and compare these fractions, okay? They have different numerators and different denominators. We're not going to check it with the drawings. We're just going to use this drawings to compare it, and you can easily see that this one's going to be the greatest of the two fractions. All right, so when we do the math, it should come out that this one's greater, okay? So let's see what is this fraction. Well, we have 1, 2, 3, 4, 5, 6, 7. We have 3/7 versus 1, 2, 3, 4, 5, 6, 7, 8, and there's just no way we're going to be able to draw this accurately in any form. Okay, 2/8. So we're going to compare those two, and I'm going to use the cross multiplication method. So let's go ahead. 3/7 compared to 2/8. Okay, if you remember, do you remember what to do? That's right. You multiply the numerator times the denominator. So you get 3 times 8, and then you make your line, versus multiply this times this, 7 times 2, and now multiply those two, but put them in both 7 times 8, 7 times 8. Okay, now you're supposed to have your multiplication table, but more importantly, you're probably supposed to already know these fractions. So this is the same as 3 times 8, that's 24. Sorry. Let me go ahead and change that one. Okay, that's I'm gonna put this one in blue. That's 24, and 7 times 2, that's 24, right? And this is 7 times 2, which is 14. And since we're multiplying to get the same denominator, we have 7 times 8. You remember that? That's 56. And that's 7 times 8. That's 56. So what are we comparing then? We're comparing 2456 versus 1456. My denominators are the same, so the fraction with the greatest numerator is the greatest. That's this one. So that means, remember that 756 is the same as 3/7, and 1456 is the same as 2/8. So that means that 3/7 is greater than 2/8. Okay, I hope you were able to do that. This is really 4th grade, so if you're a little bit lost, that's okay. Your teacher will be able to teach you this later on during the school year. So this is just an introduction to that, okay? Now let's go to the last exercise. Okay guys, for this final problem, let's pretend you are a contestant in a game show okay? And you are asked to select between 2 rooms, room A and B, okay? In room A, in both rooms there are presents, okay? And there are white presents and there are red presents. The white presents have $1,000. Excuse me, the red presents have $1,000. The white presents don't have anything, okay? Room A has 4 out of 6. 1, 2, 3, 4, 5, 6. 4 out of the 6 presents are red. That means you have 4 out of 6 chances of winning $1,000. In room B, 5, 2, 3, 4, 5, 6, 7, 8. 5 out of the 8 presents have $1,000. Now you're asked to pick a room to see where you have the best possibility. You only get to pick one box. The best chance of winning those $1,000. Now, most of you will say, well, yeah, room B has more gifts with $1,000, so I'll go in there. That is true. It has more than room A. But if you look in room B, you have 1, 2, 3 boxes that don't have anything. So you could lose if you pick those boxes. And remember, you can't tell which ones have which ones are red or not. I just made that to make you look at that. And in room B, you have you have 2 only that don't have any prizes. So there are less boxes with $1,000, but there was also less chances of not winning those $1,000. So you have to make a decision. Do you want to go with 4-6 with a room that has 4 out of 6 chances of winning, or with a room that has 5 out of 8 chances of winning? Think about it. Let's do this mathematically. Okay, we can do this mathematically and pick the best chance mathematically speaking. Okay, so what we need to do is which is the greatest fraction, 6/4 or 5/8. They have different denominators and they have different numerators, so we can use the cross multiplication method. So let's go ahead and do that. That's why we learn math, right? 6/4 compared to 5/8. Okay, it's no secret, we're just going to cross multiply. Let's cross multiply 6 times 5. Okay, and let's cross multiply, remember, 4 times 8. Then let's find a common denominator by multiplying the denominators 6 times 8. So 6 times 8 and 6 times 8. That's going to be your common denominator. Put your equal sign here. Now let's turn those into fractions. What's 6 times 5? Well, if you count by 5 6 times, you'll get 30. What's 4 times 8? If you count by 8 twice, you get 16. You double that, you get 32. Okay. Now your denominators is 6 times 8. You remember 6 times 5. 6 times 8. 8 times 5 is 40, and 8 more is 48. So you have a common denominator of 48. Now you have the same denominator. Now you need to pick the one, if you remember the rule, the fraction with the greatest numerator is the greatest when the denominators are the same. So this is the greatest fraction. So indeed, picking 5/8 is better than picking 4 6s. Okay, but it's actually pretty close. You have just about the same chance of winning, but still, you want to go with 5/8 because when you look at the common denominator, 6/4 is the same as 30/48, and 5/8 is the same as 32/48. So, but just by a little bit, you're better off going to room B. All right, I hope you enjoyed that. And that is the end of this class. You have a few exercises to do on your worksheets that I sent you. Please remember to do your 30 minutes of reading and your 30 minutes of Imagine Math. And if you haven't done them at all this week, then you need to do 2 hours before the weekend ends, okay? So this is a pretty lengthy class, but that's usually the way we do it. If we're in class, that would be any different. You would just have more chances to participate than the one, than here, okay? So I hope you enjoyed it. I hope you relax. Have a great weekend, and I'll see you Monday with a reading class, okay? We're going to keep reading 20,000 Leagues Under the Sea. Thank you very much, and see you next time.